In this lesson, we're going to look at what absolute convergence is. So absolute convergence says that given any series, we can consider a corresponding series, which is the same series with the absolute value. So if you remember right from one of the other lessons when we looked at alternating series, this basically makes all the values going to be positive. So the definition of an absolute convergence says, if series A is absolutely convergent, if the series' absolute values is convergent. So if I look at the series as all positive values and that is convergent, then the original series is absolutely convergent. As long as the series is all positive values to begin with, it's automatically absolute convergent. So this only comes into play when we have series that are not, or positives and negative values in there. Okay, let's look at a couple examples of series that are either absolutely convergent or not. The first series I'm going to look at is an alternating series, -1 to the n minus 1 over n squared. So the series comes out as 1 minus 1 over 2 squared plus 1 over 3 squared, and so on and so forth. If we take the absolute value of this series, the new series is in essence just 1 over n squared. Now, 1 over n squared is a p-series with p equals 2. Since it's a p-series and the p value is greater than 1, therefore the series is convergent. So I know this series, original series, the -1 to the n minus 1 over n squared, is absolutely convergent. The next series we're going to look at is an alternating harmonic series. We know this one is convergent because we did the test in the alternating series test. So the alternating harmonic series is convergent. However, if I do the absolute value of the alternating harmonic series, I get the harmonic series, which is a p-series with p equal to 1, and we know that that is divergent. So, unlike the last example where it was convergent, therefore absolutely convergent, this series is known as conditionally convergent. Conditionally convergent means that one series is convergent, but it's not absolutely convergent. So the alternating harmonic series is convergent, and it's conditionally convergent because the harmonic series is not. The takeaway from this is if the series is absolutely convergent, then it's always convergent no matter what. If it's the negative version, the positive version, or an alternating version of it. However, if it's conditionally convergent, it's only convergent in certain situations. The next series we're going to look at is cosine of n over n squared. And as you can see, this one goes cosine of 1 over 1 squared, cosine of 2 over 2 squared, and so on and so forth. This series has both positive and negative terms, but they're not alternating because at some point cosine is going to become negative, but it's not at the next point. It just depends on if we're looking at degrees and radians and a lot of other things, but it is definitely not alternating. So we need to figure out if this series is convergent or divergent. The method we're going to use is we're going to look at the absolute value of it and see if it works that way. So we take the absolute value of cosine of n and n squared. N squared is, the absolute value is still n squared, so we don't have to worry about that. Now, so I have the absolute value of cosine of n. I do know something about the absolute value of cosine of n. I know it has to be less than or equal to 1. So that means I know that cosine of n over n squared is less than or equal to 1 over n squared. Now, that's very important because 1 over n squared is a p-series and p is 2, therefore it's convergent. So because of the comparison test that we talked about before, I can say that the original series is also convergent, or the absolute series that I just did, the cosine of n over n squared. Because it is always going to be less than 1 over n squared, and so it's bound by that, and it's decreasing. So therefore, it's got to be convergent. Since the absolute value of it is convergent, that means the series is absolutely convergent, and therefore the original series is also convergent because of the absolute convergency theorem that we talked about.